Okay, so welcome back. In this lecture, we will take a quick look at the Unix operating system. Some of you might have used it. I've been using it for a long time, and I like it very much, and it's something that I think everyone should know about. Okay, let's take a quick look. This is a brief look at the Unix operating system. This is chapter 2 of the Afzal book. In this chapter, we will look at the history of the Unix operating system. We won't go into a lot of detail. It's not that important. And then we will look at how Unix developed over the years. Look at some of the major Unix versions. So there's too many versions to really be able to look at more than just a few. Okay, brief history. The Unix operating system was the brainchild of two people, Ken Thompson and Dennis Ritchie, who used to work for AT&T or Bell Labs. Universities and colleges played an important role in the popularity of the Unix operating system, mainly because these two people and Bell Labs made Unix available to universities all over the country and all over the world. And the University of California, Berkeley, is one of the main universities that used Unix, and so you will see a version of Unix called Berkeley Unix. That refers to University of California, Berkeley. So there are two main versions of the Unix operating system. If you say Unix, you mean one of these two. Typically the former. That's the AT&T Unix. It's not called AT&T Unix anymore, but most people still refer to it as that. Okay. So in the original Unix code, there was the very first ones were pretty much mostly written in assembly language with a lot of C, and the later ones, about 95% of the operating system was written in C. Just 5%, very small part of it, written in assembly language. So assembly language is specific to a certain CPU. So if you want to use Unix on a different CPU, you have to write all new assembly language. That's okay if it's only 5% of the code. Maybe it's not that big a deal. You don't have to rewrite the other 95%. You just have to compile it from C into machine language. Okay, so a very small part of Unix probably is still written in assembly language, and that's the part that's mostly concentrated in the kernel, and that interacts directly with the hardware. Okay, so it turns out there are other Unix systems. We will be using Linux just because it is free, it's easy to get at, easy to customize, and I can give you a Linux system on a DVD. And it's pretty much a full operating system right there in a DVD. There's also Solaris. We use that on campus. A lot of our administration, a lot of our servers will use Solaris. Then there's also Unixware. Now the other things you have to know about X Windows is the graphical environment that we will use, that almost every Unix uses. X Windows, it was developed at MIT. It was not actually part of the original Unix code, but just about every Unix system will use it. So it's essentially just a graphical user interface that runs, quote unquote, on top of the Unix operating system. So we saw in the last chapter how there are these layers of software. At the lowest level of software is the kernel, which interacts directly with the hardware usually. On top of that is, in this chapter, they call it the resident modules layer. So there are different modules that handle parts of the operating system. And then there's the utility layer, which is the Unix user interface. And it's also referred to as the shell. You might have seen this in Mac OS X and Windows 2. So, and typically on top of these three layers will run the graphical user interface. So, and you can also bypass the graphical user interface and go directly to just the shell. And we will do that. We will do that in the lab. We will look at a server where we access only the shell. There is no graphical user interface in that system. For the DVD that I'll give you, you will have a complete graphical interface. So So sometimes you will see this picture, sometimes you won't see quite as many layers. So for example, in this picture, we have the hardware, the kernel runs directly on top of the hardware, and things like the resident modules, parts of the operating system, and then the shell, which we will be using, run quote unquote on top of the kernel. And the user interacts directly with the shell. The user never actually interacts with the kernel. Never. Let's just say never. Although in later courses, you will start using the kernel. But say most users, almost all users, at the most they will interact with a shell or a graphical user interface. That's even easier to use than the shell. Okay, so what are some of the features of Unix? It's portable, that is, you can put Unix on just about any hardware. Any chip that you've come up with, there's probably a C compiler for it and a Unix system for it. It can support multiple users, it can do multitasking. What that means is it can make it look like it's running multiple things at the same time. It can support a hierarchical file system. What does hierarchical file system mean? It just means that in one directory or folder you can have multiple files or folders, and so in these folders you can have multiple levels of folders and things like that. So that's the hierarchical file system, which just about every file system is right now. You can use device-independent input and output operations. That is, when you type in stuff at the keyboard, you don't have to worry about exactly what kind of keyboard it is. It can even be a touch screen, things like that. And sort of doesn't make a difference to some of the programs. Unix also has a nice shell, which is just about a must that you have to learn if you want to say that you're a Linux user or a Unix user. And then once you learn how to use the shell, you'll start setting up programs that are written using shell scripts. Okay, so those are all things we will do. The Unix system has just hundreds, thousands of programs. There are some basic ones that are also called commands that exist on just about any version of Unix, whether it's Linux or Mac OS X. Things like that, you will see the same commands. That's just a standard feature of Unix. Okay, so there are also utilities for text editing, text formatting, file manipulation, for email, all kinds of tools for programmers, compilers, debuggers, things like that. There are system administration services. Now, this is one of the main reasons for really learning Unix, is there's so many jobs these days that depend on you knowing about system administration commands, system configuration, file system maintenance, and then file transfer, all of these things. If you know some of the main commands and how these work in Unix, chances are you can get a pretty nice job when you graduate, or even before you graduate. Okay, so let's stop here. We will look at some of these things in the lab, but just want to give you some rough idea of what some of the main components of Unix are and how they came about.